Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSC, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. This series of lectures cover mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. The content of today's lecture is about the GSM network architecture. The subdivisions of the GSM architecture includes 3 parts. They are radio subsystem, network and switching subsystem, that is referred as NSS, and the operation subsystem OSS. In the previous lectures, we have discussed about the first subpart, that is the radio subsystem has been covered. Today let us discuss about the network and switching subsystem as well as the last one, that is operation subsystem. Let us discuss one by one. This is the functional architecture of the entire GSM network. In the diagram itself, we can locate OSS, and the second one is NSS, third one is OSS. Now, we have discussed enough discussion about the radio cell, the coverage, BSS, BTS, and how mobile users are connected to the GSM network through the UM interface, everything. Today's discussion is purely about the NSS and OSS. Now, as the name says, the network switching subsystem forms or creates the entire backbone architecture or backbone network for the entire GSM network. It includes mobile switching center, that is MSC, and VLR, that is visitor location register, and home location register. The MSCs are connected with the outside networks like PSTN, PDN through the gateway mobile switching center. Let us discuss how these kind of things are used in the GSM network. So, various kind of subparts or subcomponents are integrated in the NSS layer. Let us start and discuss one by one. GSM system is formed by the network and the switching subsystem. So, as I already mentioned, the GSM network's backbone is the NSS. So, various kind of mobile users, they are connected to the GSM network, and that users are connected to the outside users. They are connected with the outside networks like PSTN. So, through the NSS they are being connected. NSS connects the wireless network with the standard public networks. Wireless networks, nothing but the mobile users. So, they are supported by the mobility support, and now the mobility supported users are connected with the outside network through the NSS. So, NSS performs handovers. So, what is a handover? As the users are free to move even after establishing the channels or even in the calls or in progress, the users can move from one cellular station to another cellular station. So, this kind of facility is supported by the GSM network. Now, the NSS performs the handovers between the basic service stations or basic service. Many BSSs are connected to the NSS. Now, the mobile users from one BSS can be moved to the another one BSS. So, that support is known as the handover support. So, NSS supports that handover, and localization of users is a mandatory function. How to localize the user? So, a particular user maybe keep on moving from one location to another location. So, worldwide, through the worldwidely, the users has to be located. So, now NSS supports the localization of users. So, it uses various kind of databases like HLR, VLR to locate the users. And the very important aspect regarding the NSS is charging, accounting and roaming of users. So, roaming is nothing but the users are free to move from one region to another region, that is one service area to another service area. And how to charge the users, that is a very big question. Now, based on the tariff and based on the region they are moving, the NSS will support the charging and the corresponding accounts. So, this is in the perspective of the service provider. So, in their perspective or in their business perspective, they will charge the users. They are doing all these kind of process using the NSS. We can consolidate the entire functionality of the NSS like follows. So, NSS has the following switches and databases. So far we have discussed what kind of functionalities are supported by the NSS. Now, how the NSS actually handles or supports these kind of functionalities. So, to manage all kind of things, it uses some kind of switches as well as databases. Now, the first one is Mobile Services Switching Center, or in sometimes it is referred as Mobile Switching Center. So, MSC stands for Mobile Services Switching Center as well as Mobile Switching Center. Both terms are same. Second one is Gateway MSC or GMSC. Third one is Inter-Networking Function, or it is referred as IWF, and two kind of databases are used by the NSS. So, the first database is Visitor Location Register, that is VLR. The second database is referred as Home Location Register, that is HLR. Let us discuss one by one. Now, we can locate all kind of databases and switches in the NSS layer. Now, Visitor Location Register and Home Location Register, so they are connected with the MSC, and the line says that many MSCs can be connected together, and this is the interface A. Now, the A interface connects an MSC with the BSC. So far, we have listed some of the switches, high speed switches and databases of the NSS layer. Now, in the functional architecture of the GSM, that is the global system for mobile communication, let us locate all kind of components, that is the switches and databases in the diagram. So, as I already mentioned, this is the network and the switching system layer. In this layer, VLR, HLR, they are connected with the MSC. Now, this line says that many MSCs can be connected together, and MSCs are connected with the outside network, other networks, other fixed networks like PSTN, ISDN. So, these kind of interconnection also supported by the GSM, and this is the interface, the special interface A. Now, this A interface defines or specifies something about the connection between the mobile switching center and the BSC. Now, let us discuss in depth about the mobile switching center. So, mobile switching center, they are the very high performance digital switches. What is a digital switch? So, all the mobile users, they are the radio users. They are free to move, they are not connected to the network with a wired. So, through the wireless medium or through the air medium, all the users are connected. Now, all the wireless users are connected with the tower. Now, the MSC switches or forwards that kind of connections to the outside world. So, MSC performs that kind of switching or forwarding operations. So, MSCs set up the connections to the other MSCs. As I already mentioned, two MSCs can be connected within the GSM network itself. So, the connections can be transferred between the two mobile switching centers, and MSCs and BSCs are connected. So, As I already mentioned, the base station controllers are directly connected with the MSC through the A interface. So, a particular MSC or a single MSC can control several number of BSCs. So, as we already discussed, this is the fixed backbone network. It connects the radio users to the GSM network as well as to the outside world, and MSC manages several base station controllers. So, in geographical region. So, in a particular region or in a particular space, many base stations can be there. So, these all kind of BSCs can be connected to a single MSC. So, now another one term is GMSC, that is gateway. So, in general, gateway specifies that outside world. Now, radio users are connected with the GSM network. Now, the GSM users should be connected with the outside world. That is achieved using the gateway MSC. So, that is referred as GMSC. So, some example fixed networks are PSTN, that is public switched telephone network, as well as the ISDN networks. And one more important switch in the NSS layer is IWF, that is the inter-networking function. So, this is also a kind of high speed switch. Now, that switch specifies some extra functions or facilities or specifications to connect the GSM users to the public data networks. So, for example, X.25, these are all the standard which follows the architecture of the public data networks. Now, IWF specifies how to connect the GSM users to the public data network. In the previous lectures, we have learned about the supplementary services like call forwarding, multi-party calls and all. Now, these kind of supplementary services are supported by the mobile switching center. So, mobile switching center is NSS in NSS layer. And another one very important aspect about the mobile switching center is signaling. Now, how to signal? As I already mentioned, the radio users are connected with the GSM network and the GSM users are connected with the outside network. So, there should be some signaling or some protocols. Now, GSM users a special signal number that is referred as SS7 that we will discuss later. Now, the signaling is handled by the mobile switching center. So, what kind of signaling? To set up the connections. Once the call is getting over, that connection should be released. So, the connection release is handled by the mobile switching center, and handover of connections to MSCs. An user may move from one BSS to another BSS. So, in that situations, the mobile switching center has to do some signaling. So, to achieve the handover, they have to do some signaling. So, these kind of signals are referred or specified in the SS7. So, that is referred as standard signaling system number, or in sometimes they used to call as signaling system number also. So, actually they handles, or we can say that MSCs uses SS7 for their signaling operations. So, now let us discuss about the SS7. So, this is very important specification, very important signal, as the MSCs follows the SS7 format or specifications for signaling. So, SS7 covers all aspects of control signaling for the digital network. So, that include reliable routing. The calls should be routed between the users and to the other end users properly. So, these kind of activities can be achieved by using SS7. And delivery of control messages. Sometimes we used to get the control messages from the network itself. So, these kind of control informations are delivered through the SS7 signal. And establishing and monitoring of the calls. If a particular user is making a call, the call should be established, that is the channels are assigned. Now, after assigning all the channels, they used to speak. Now, that channel or that connection should be monitored. So, if some error is occurring, so it has to be handled. Let us have a short break. After the break, let us discuss about the remaining registers and databases as well as the remaining GSM architecture. Welcome back. Before the break, we were discussing about the various kind of switches. So, let us continue from the various kind of databases used in the MSCs. The first and very important database which is used by the NSS, that is a network and switching subsystem, is the home location register, that is referred as the HLR. The HLR stores various kind of informations. Let us discuss one by one. First of all, it stores the mobile subscriber ISDN number, that is MS ISDN, and it stores the subscribed services. For example, a particular user can be subscribed into n number of services that is supported by the GSM network. For example, call forwarding services, roaming restrictions, or they can avail some GPRS, like that general packet radio services. So, these kind of informations can be stored in the HLR. So, based on that, the users will be charged to maintain the account details and charging and all. The network will use the HLR location. And the very important number which is stored in the HLR is IMSI, that is International Mobile Subscriber Identity. Actually, these numbers are burned in the SIM card, that is a subscriber identity module. So, these numbers and these kind of informations are actually used to charge the users, to locate the users while the users are in movement. So, the numbers what we have seen, they are the static information. So, IMSI numbers, and these numbers are stored once for a individual user. So, they are referred as a static information. Now, the HLR also stores some dynamic information. So, what is the need for the dynamic information? Why should the dynamic information have to be stored? As I already mentioned, the users are free to move. So, they will keep on moving from one location to another location. Even they are able to make a call, they are send a packet, even they are traveling in a train or bus. So, the kind of mobility support is provided in the GSM network. As the users are traveling in the car or train, their locations will be keep on changing. So, definitely that users location are to be updated to exactly locate the users, their locations as the users are moving, that location should be keep on updating. So, this kind of dynamic information is supported by the HLR. And mobile subscriber roaming number, that is referred as MSRN. Now, whenever the user is entering into the new location area with respect to the cellular coverage, they will be provided with the various MSRN. Using or mapping this MSRN with the user's static information, we are able to, or the service providers are able to locate the users. And current visitor location register and current MSC. So, these kind of informations are stored in the home location register, but that comes under the dynamic information as the informations are keep on changing. So, as soon as the MS, that is the mobile station or the wireless users leaves the particular LA, that is the location area, it is referred as the current location area, that information is updated. The HLR for an individual user is unique, that is for a single user there will be a single HLR. Many HLRs are distributed, but for a particular user their static information is stored only once in the HLR, that we should understand. So, wherever the users are moving, their locations, their current locations, everything will be updated in their own HLR. So, as I already mentioned, this kind of current locations and dynamic mobile subscription number, all the informations are used to locate the users. So, at any point of time, an user in the GSM network can be easily located. So, these informations are referred as user specific informations. For example, as I already mentioned, for a particular user only once the information, that static information is stored in the HLR. So, using these location areas and current MSC details and the roaming details and their supplementary details stored, the users can be easily charged. And you know, the HLR is capable of storing the records for million customers. So, the special kind of databases are used. Ordinary databases are definitely not suitable for these kind of applications, because a huge number of users may request some informations. So, that database should be able to process all kind of queries within a short response time. So, the HLR, they are using the very specialized databases to fulfill their real time requirements. Second kind of database of the NSS layer is known as the visitor location register. As the name says, as the users are visiting the new current location area, some informations are to be updated, and that updated informations are communicated with their HLR. So, how the VLR is working? Let us discuss it now. So, the VLR associated to each MSC, that is individual MSC, they have their own visitor location register. So, n number of users may be entering into the particular MSC. So, all kind of users can be recorded in the VLR. So, VLR stores all important informations needed for the mobile users currently in the location area. Using the VLR information only, we are able to identify where the users are currently. Some informations, they include IMSI, MS ISDN and HLR address. Already we have discussed about these numbers. Now, the VLR uses these kind of informations to locate or keep on monitoring the wireless users. Whenever the mobile station is entering into a particular or new location area, now it is a responsibility of the visitor location register to update or contact the HLR to do all the consequences. Now, it copies all the relevant static informations from the HLR to the VLR. Some VLRs in existence, they are capable of managing even 1 million of customers. So, they are using the very special kind of databases to manage all type of real time requirements. So far we have discussed about the second subsystem of the entire GSM network, that is the network and switching subsystem. Now we are entering into the third architecture, that is the operation subsystem, that is referred as OSS. So, this is also a very important component or part in the entire GSM network, as it supports various kind of operations for the GSM network. The operation subsystem contains the necessary functions for the network operation and maintenance. The network has to be maintained to provide the better services. So, where the users are going, how to charge the users, what are all the problems, real time problems are occurring. So, these kind of network related informations are managed and handled by the OSS. So, OSS has the following network entities. Let us see one by one. So, the first and very important component of the OSS is Operation and Maintenance Center, that is referred as OMC. Now, the OMC monitors and controls all other network entities via O interface. The O interface connects the NSS layer and the OSS layer. Now, the signaling number 7, that is SS7, is used by the layer to connect the NSS with the OSS. Let us discuss the special functions supported by the OMC one by one. Now, traffic monitoring. What about the traffic? How many users are connected at the right time to the network? So, how to manage? What about the workload, or what about the overhead of the particular base station controller? So, these kind of traffic monitoring are performed by the OMC. And some status reports. So, based on the monitoring, some monitoring data or information about the current situation about the network has to be prepared by the OMC. So, various kind of network entities are keep on monitored by the OMC. And subscriber and security management, what are all the tariff plans are used, and what about the security issues, are they transferring the secured data, are we providing some security to the data transmission. So, these kind of informations are purely handled by the OMC. And as usual, accounting and billing. And we should know one thing, as the users are moving from one place to another place, and the users are making the calls for some times. So, all these kind of the usages and the current location areas and the roaming areas are updated using the VLR and HLR. Now, OMC uses these informations to perform the subsequent operations like billing and charging. The next very important component of OSS layer is AUC, that is referred as the authentication center. So, what is an authentication? So, the users are to be authenticated. So, to maintain the security problems or to handle the security issues, we are supposed to, or any kind of network providers are expected to provide some security mechanisms. Now, OSS layer in the entire GSM architecture takes that responsibility. So, the radio interface and mobile stations are particularly exposed to many kind of problems, because we cannot put the boundary to the wireless signals. So, the wireless signals can be penetrated to any place if possible, or they can be easily hacked. So, how to handle these kind of problems? So, now AUC takes care about all kind of problems. The GSM service providers, they are running the separate AUC, or that is known as separate AUC. It is defined to protect the user identity and the data transmission. So, it ensures the secret or secured data transmission. It identifies the right and valid users. Sometimes malicious users may try to enter into that network. So, at that situations, only the GSM network should allow the users to enter. That user should be an authenticated users. So, AUC contains some algorithms for authentication. So, many kind of algorithms are used to provide the security. So, the authentication center of OSS ensures the secure data transmission and secure user identity. From the functional architecture of GSM, we are able to identify all the components almost, like NSS components, RSS components, including VLR, HLR, GMSE, and in the OSS layer also we have covered OMC authentication center. In the next lecture, we will cover about the EIR, that is Equipment Identity Register. Let us summarize what we have discussed. NSS, that is a network and switching subsystem, is the heart of the entire GSM network. NSS connects the wireless users with the backbone GSM network. NSS localize the users. The fixed backbone network of GSM is formed by NSS with the various components like high speed switches and HLR, VLR databases. MSC uses standard signal number 7 for signaling for various kind of call activities. Static and dynamic information about the mobile users are stored in the HLR and VLR registers in NSS layer. OSS layer of the NSS contains the necessary functions for the operation and maintenance of the entire GSM networks, that including charging and accounting of users. Authentication center of OSS ensures the secure data transmission as well as the secure identity of users. Let us pose some questions for our understanding what we have seen in the lecture. Which subsystem of GSM performs the handovers between the different BSS? Which interface connects MSC and BSC? How could the position of an MS be localized? What is the use of International Mobile Subscriber Identity, that is IMSI? With this we conclude our lecture. We will discuss about the Equipment Identity Register and the remaining protocol architecture of GSM in the forthcoming lectures. Thank you.